Hello, everyone. Thank you for coming tonight. Thank you for Sadiq and the organisers again, putting on this event for 25th time. Came here on what feels like a long time ago when it was in its infancy, 2-3 years ago now. Yeah, very early days, and it's good fun to be back here all this time later, seeing what it's grown into. Who am I? Like I said, Dave, I'm CTO at Stelia. I'm a software engineer, system admin, network monkey. I've done it all at one point in time. I'd say more importantly, I'm a passionate technologist, hence why I come to places like this. I love being part of communities, open source developer, user, and enthusiast. I've been a distro maintainer at one point in my life, contributed bug fixes and feature development back to sort of user space programs at some point in time, and still champion open source as much as possible. More importantly, I'm a problem solver. I like solving problems. I don't like reinventing the wheel. I like finding new problem spaces to go and look at. Why are we here? We're going to be talking a bit about where we're at as an industry. Hands up if you know what the difference between inference and model training is. Good, don't expect anything less, but it's always a good start. But yeah, as we can see, inference process where a trained machine learning model analyzes new unseen data, make predictions, decisions, generate context. Where it becomes a product is where you start taking those models as a software solution, API, or a platform, and you design this to apply a pre-trained AI model to new unseen data, like we said. Very common, like we said, taking this into different markets, let's say healthcare. You might be looking at patient data, so on and so forth. What's a market-specific product vertical? At Stelia, we've sort of chopped the market up into a few different verticals. Media and entertainment is one we've got primarily, and we look at this as a sort of ad tech space, video and image generation, quite a bit of generative AI alongside just traditional language models. I had quite a bit of background in ad tech. This was a good low-hanging fruit for us. I had sort of fallen into machine learning by accident when I worked at an ad tech company. Started off building fraud products and then starting to moving into doing things like neural networks for behavioral groupings, dynamic audience building of a marketing campaign, lots of other interesting stuff. Retail and e-commerce is another one. Agriculture is another one that we've sort of fallen into by accident. I'll touch on that a bit more. Breakdown of the inference products. I'll just sort of run through that. You've obviously got the data. Can't have an inference product without data because, like we just said, you're introducing new data to a pre-trained model. The transformation piece of it is also quite, before I go to transformation, the collection and transport. What I mean by that, you then have to take that custom data in from somewhere. Most companies will generally start off just taking in static data sets that they can import from whatever database. By the time you get to dealing with real-time data, you'll probably be looking at doing things like setting up Kafka infrastructure for real-time data ingestion. Own set of challenges, but yeah. Transformation, taking that raw and structured data, structuring it ready for use. The model inference and service. This is the model logic, the weights and architecture, optimization, quantization, inference engine itself and how it gets executed and exposed via an API. I think most people here is probably familiar with OpenAI and how everything similar to that now gets called like, oh, do you have an OpenAI style API to consume? API gateway, this is another interesting piece, sort of a front door to the inference system. Like anything in the sort of traditional cloud space, it would handle your authentication, authorization, rate limiting, all that type of stuff. Orchestration, you typically have to orchestrate this somehow. I think I had a conversation at the beginning of the night where we're talking about, yeah, you can just run VLLM or something on your MacBook and play around with it, but actually orchestrating that across maybe 250, maybe even 1,000 users presents its own challenges. Like anything in life, scaling beyond one machine or one user obviously changes the scope and design. The infrastructure compute clusters as well. This is the other interesting bit. If you actually self-host this, hands up in the audience if you've self-hosted anything like this. And by self-host, I mean an NVIDIA gaming GPU, a 5090, anything. Doesn't have Fine, it's still an accelerator. It doesn't have to be a big billion-dollar cluster. Show of hands. Okay, decent amount. Hands up if you're using cloud providers, AWS, anything else. Okay. Hands up if you're using both. Interesting. It's an interesting space we fell into as well, because we were targeting sort of enterprises that might be wanting to have 1 foot in cloud and 1 foot in self-hosted. And again, presents its own challenges, having to sort of target multiple backends, so to speak. You might get to the point where you want to introduce sort of feedback and continuous learning to your inference product. That's usually a bit ahead of an MVP. Security and governance is a big one as well. Enterprises today want all of this logged and auditable because they get audited on a semi-regular basis, I would say. Some of the people we've spoken to in the past sort of 12 to 18, even 24 months, it's CIOs, CTOs that are having nightmares about all the sort of shadow IT infrastructure that they're seeing introduced to their business. Or people being told like, oh yeah, I'm just taking company data and putting it into ChatGPT and Grok and everything else. And yeah, CIOs are losing sleep over this type of thing. Architecture, as I try to split this into sort of two, you'll either have a sort of static data model only. We've got a customer like this at the minute. They've started off on static data, but they will at some point in the near future migrate to real-time data. This is important sort of media and entertainment. You might have real-time ad campaigns. Not enough just to take a previous ad campaign and do some data analysis and machine learning on it. You might want to see how your ad campaign is performing in real time. It might be in agriculture where you're taking in data from satellites. That's all coming in real time. So again, takes you into the territory of requiring things like Apache Kafka or something similar. Let's just say there's no free lunch. Looking at the product piece of it, this is where it gets really interesting for me. It differs per technical error. Sorry, brain's not working. I'm dyslexic, so this will be quite simple and probably expect lots of mess ups like that. The technology differs per market vertical. We've sort of split these up a little bit, as I mentioned earlier. Start looking at fintech, where you start looking at anomaly detection models and predictive analytics. I've had a bit of playing around with this in my own time with things like Polymarket, looking at doing user groups and behavior groupings. I'd done a little research project of what I termed was detecting coordinated information advantage, and another word for insider trading, but based off machine learning models rather than just, oh, someone sharing information. Retail and e-commerce is also really interesting. Lots of forecasting models and recommendations engines that would be based on, again, consumer profiles, the sort of what they've been buying to date. We've done a little bit of looking into that market. We've got our sort of first eyes on what the technology would be going forward with that. Media and entertainment, again, I said that was the sort of first one we spearheaded based on my background. Lots of generative AI, lots of recommendations engines. The big problem with it, however, is compliance. As we know how advertising has evolved in the past 5 years, if you're advertising to, say, children in different geographical regions, that you have to be able to prove I didn't show them naked people and everything else. So that's where the governance piece comes in, very, very important. Legal is another one. We've got an in-house legal counsel as well, and we were able to pick her brains a lot on how introducing AI to legal professions would look. Lots of natural language processing, as you can imagine, ingesting lots and lots of text data and basically just putting it into a vector database and being able to search it and query it. Healthcare and life sciences is another interesting one to us. We have our first foot into that market as a sort of initial understanding of what it could look like. Computer vision is a big one. Lots of using, again, sort of neural networks, whether it's graph neural networks, convolutional neural networks, as opposed to just models. So a little bit different in this. Definitely, as I'll come to on the infrastructure slide, how the underlying resource gets utilized on a sort of scaling basis. Agriculture, this is what I touched on earlier. This is really interesting. So we have a customer at the moment. They started off as a research project in a university in England. They spun out of the university into a commercial sort of startup. They do lots of things like weather modeling for crop yields and lots of interesting things in that space. Really, really based strongly on deep learning and neural networks as well. A little bit of generative AI and also ML. That's the customer I refer to who would be switching from just taking a large volume of data set from satellite ground stations, doing their weather modeling based on static data, but they'll eventually in the near future move to taking the data live from the satellite ground stations themselves. So that's going to be a very interesting challenge. Common path to a proof of concept, prototype, MVP, call it what you like in this space. Hands up if you've built a prototype of inferencing. Good percentage of the audience. That's good to us. Hands up if you were happy with your prototype. Took me a long time to get anywhere close to happy. That's all I'll say. Yeah, so back to what we said earlier, data. Machine learning and AI starts with data. Garbage in equals garbage out. You need to have quality data to begin with. If you don't start designing this with data in mind, you're wasting your time, quite frankly. The inference engine piece is quite interesting as well. VLLM is a nice piece of software out of the University of Berkeley in California. Produced many interesting things over the years, such as BSD and everything else. But VLLM is the latest piece of quality software to come out of Berkeley. LLMD is a sort of newcomer to the inference engine space. Red Hat authored that software last year, and that's more of a means of having a sort of Kubernetes native VLLM. Part of this is due to VLLM requiring an external control plane for scaling on user consumption. Got software in there like AI bricks, and again, lots of issues with multi-tenancy, shared API keys. I'll come to that in a bit. The infrastructure and orchestration piece, as I just touched on, Kubernetes is generally sort of what most people use these days. Hands up if you're using Kubernetes. Good percentage of the audience. Hands up if you're using anything else like OpenStack or whatever. Using both. Oh, you get no sympathy for me, mate. I've known Otti a long time, so we've got a lot of inside jokes. Yeah, Kubernetes is quite common, but like I touched on, integrating VLLM into Kubernetes in like a programmatically controlled, reproducible manner can be quite challenging. Sure, you can just create a compute instance like EC2, you can set up VLLM there and start using things, but how you actually take that to tens, if not hundreds of thousands, if not millions of consumers doesn't scale beyond that. So you need that integration with Kubernetes that VLLM to date doesn't have, and LLMD seeks to introduce. The infrastructure piece, as I said, you'll either have to host this on your own GPUs or you'll have to consume GPUs in AWS, GCP, wherever else. You might be a madman like me at Stelia and you end up having to host it on both, which is not what you want to be doing, but it does have its own pros and cons. The product side of things, as I touched on, most people are familiar with OpenAI style APIs, whether it's calling API endpoints for images, videos, that type of thing. The gateway implementation, most people overlook this and then wonder why they're not able to enforce rate limiting on consumers. I think everyone in the audience is probably familiar with rate limiting on things like Claude and Grok and everything else, and how they started off giving you, oh, you can generate as many videos as you want, then they put limits on videos, and now it's limits on images, and it'll probably be limits on everything by the end of the year. So yeah, getting a good separation between the gateway for having all core authentication, authorization, logic, everything there, allows you to mean that your product, like any piece of good software engineering, you can keep it focusing on the business logic only. Problems, lessons learned, everything in between. Inference engine, VLLM, multi-tenancy was not a priority upstream, and a little bit unfortunate pinning this entirely on VLLM because, as I alluded to, it needs sort of external control plane for orchestration. The one that has been used to date was a piece of software called AI Bricks. AI Bricks works quite nicely. Hands up if you're using VLLM, actually. Small amount of people, but what control planes are people using with it? Have you used AI Bricks or LLMD? What are you going to tell me?
It was the one we heard about on the last MLOps meetup from the internet.
Oh, that one, yeah. Okay. So yeah, AI Bricks is a control plane for VLLM, allowing you to scale it beyond your MacBook, which is always a good thing. It does, however, have its challenges. When we started, like anything we do at Stelia, once we start evaluating something, we always think about how does this look at 10,000, 100,000, 1 million consumers or users, whether concurrently or just geographically distributed. But we start looking into things like this. It became very aware, or we became very aware early on that multi-tenancy was not well supported in AI Bricks. Again, it was never designed for it, so why would I expect anything different? But we inevitably asked ourselves the question, could we do the feature development ourselves and just upstream it to the project? Yeah, kick the can around a little bit, and then we actually start digging through like the issue tracker for AI Bricks. You learn that even the upstream developers can't agree on how it should be implemented. So at that point, me as a CTO, when I have to start budgeting for what is actually developed and how we take it to production, I could not confidently state that even if we spent 12 months on that, we might not get it into upstream. And like anything, you don't want to be carrying patch sets. Hands up if you're carrying massive patch sets of open source software. I think we've all moved away from that these days. Back in the old days, before businesses became open source friendly, you'd frequently find open source software in enterprise where they had dumped patch set after patch set after patch set on there, and trying to rebase it was a nightmare. Has anyone experienced that? Lived to tell the tale, got the battle scars to show for it? I think you've got a big background in Java, don't you? Or am I confusing you with someone else? Yeah, you'll probably have experienced a lot of that when you start looking at. Okay. But yeah, it's a classic thing where we want to avoid bringing in the technical debt early on. I mean, as the CTO, the one thing that I'm constantly asked, technical debt, because we don't want to just burden ourselves. So that was a big problem we had there. To put it plainly, not ideal for resource consumption at scale, data leakage, quality of service. I think quality of service issues were the other big problem. If we had multiple users on the same like physical server, there was no guarantee that you were getting an evenly sort of distributed quality of service out of this product either. You might have one person, a noisy neighbor, who's absolutely hammering the API for video generation, and the other person can't get any meaningful output from what they're trying to consume. So not ideal from a product perspective. You take that to market and most people think it's crap because you've basically got people doing a denial of service attack on the product. The resource consumption as well was a little bit not great. Idle CPU usage, not the best in the world. GPU typically, or like the GPU consumption bounds to a single node. So that goes back to the orchestration piece I was talking about. If I've got an entire cluster of these things, how do I take it beyond one server? Might need to take it to 4 servers, 8 servers, 12, so whatever it is, I might have to do that at some point. While we look at things like idle resource consumption, consuming maybe like 0.5 or 1% of a CPU, if I've got 1,000 users on that one server, I'm now exhausting the server's resources at idle. So having to consider a lot of things like that. And this comes back to where I was mentioning having a good understanding of the infrastructure piece, where you may or may not have the abstraction of cloud hiding all of that from you. Complexity and configuration, LLMD, again, quite nice. It brings in the sort of Kubernetes native side of things to VLLM. Certainly, from the initial sort of poking around at it, we found it works quite nicely. albeit like anything, it's not even been released for one entire calendar year yet. So there's always the immaturity aspect to it as well. If I start building a product on this right now, how much API breakage or dependency breakage am I going to have over a period of the next 12 to 18 months? The operational complexity part, again, Kubernetes massively increases the stack or error scope as well, for better or worse. I think most people have come to love all the goodness that Kubernetes brings in terms of auto-scaling and everything else, but debugging things becomes, hands up if you've been debugging problems in Kubernetes. Are you happy with anything that Kubernetes introduced there, or would you rather it was much simpler?
Just read it.
I'll hire you to rebuild it, Otto. You can do my job. The hosting bit, yeah, as I said, both VLLM and LLMD have challenges here. VLLM requires external orchestration to scale. LLMD pulls in Kubernetes. It's a bit of a chicken and egg problem. Long story short, we ended up being happy with Kubernetes. That was based on our sort of internal cloud software already being based on that. So we had a slimmed down version of Kubernetes that suited our needs. You will need to deliver this to customers with low latency at some point as well. In our case, we might have, let's say, small deployments of GPUs in metro areas like London, Frankfurt, and the big consideration is I spoke about noisy neighbors and affecting the output of what they're consuming. You don't want people waiting too long for their time to first token or however many tokens per second that either. Or in the case of our customer, if they're ingesting real-time data from somewhere, they get very upset in that case if their latency goes wild. The market and product verticals. This was another learning experience. Static data is acceptable for most of these. However, real-time data will inevitably become like a reality for most people. As I said, we'll take ad tech as a starting point. Most people were quite happy to start off just, let's say, this is my marketing campaign from 2025. Let's run machine learning algorithms on this, and we'll take lessons learned and try carry it into the next one. But you're inevitably going to get the real-time data answer. I gave the example as well of the company a customer we have at the minute doing weather modeling. They want to move to doing real-time data from satellites. That's going to introduce a lot more complexity for us, but who am I to tell the customer they're wrong? Model type size and version matters. This was another really interesting thing. And again, in ad tech specifically, we found like mixture of experts models were working quite nicely. This comes in, and again, while I say working nicely, it introduces its own complexity as well, because you're no longer just running the one fixed model at the one fixed size with the same fixed quantization. You're now at the stage where the mixture of X, because again, the parameter sizing is all over the place. And if I'm having to go out and budget saying I want to buy 10 servers with NVIDIA H200s or whatever else in there, I need to do sort of capacity planning and try and guesstimate, okay, based on this model being consumed, I estimate I can maybe get 25 concurrent users per GPU multiplied by 8 for the server loads. That gets me up to this total number. But if I then introduce mixture of expert models into that equation, I might be getting a good outcome at the actual product side of things. But then when I start looking at how the resources being consumed underneath, I've now got a CFO breathing down my neck at questioning asset utilization on the GPU, saying these things cost $40,000 each. Why is it underutilized? Inevitably tied to business outcomes as well. Again, obvious but not obvious. You'll start to get people asking, if I'm consuming this product, how is it impacting? Am I, with my ad campaigns, am I getting more image or video generation done faster? Is it more tailored to the user who's viewing the ads? There's a lot more things like that you have to consider rather than just offering a sort of a text prompt for ChatGPT saying, let's discuss whatever. Latency requirements can differ drastically as well, like I touched on. The ad campaign and the satellite data one, absolutely, latency is key. but there'll be other people we work with and say the retail will be latency sensitive as well, but not nearly as much. But many other sort of product verticals we looked at with regards to, I'm trying to think of one. My mind's gone blank. There are product verticals where latency doesn't matter nearly as much as the ones I mentioned. The governance becoming a product concern, as I alluded to with ad tech. You've got copyright. If you're doing image generation based on copyrighted materials, you're going to have Getty and other people breathing down your neck. We had the former interim stability CEO in our company for a while, and his life was a nightmare just based on all the lawsuits against Stability AI based off Stable Diffusion. So that was a bit of experience we were able to bring into the company from the very beginning and say, no, we do not want to do this. I don't like speaking to lawyers at the best of times. I'm a software engineer. I like building products. I do not like legal stuff. If I liked law, I would have studied law. So I keep the law stuff to a minimum. Synthetic media, brand safety. Again, you don't want to be generating things with AI which commits brand suicides. I think everyone can think of different things when social media accounts have said bad things and then people turn against a company and stop buying from that company. So if that's a human saying that, just wait until it's agents or models doing it, and you'll still get blamed because you're the one who put the model live. The regional compliance is the biggest one for us. We had a big focus on ad tech. The customer we have for ad tech is based in California, but they also have a presence in the Netherlands as well. And that introduced a lot of complexities to us about making sure that you're, number one, compliant with US federal law, but also California state law, and then sort of European Union law as well within that side of things. Very fraught with problems in that space. I had a little bit of sort of exposure to this in my previous ad tech background, but it's something that's grown arms and legs, and I would say the past 4 years for sure. Semi-sane path forward. Exclude real-time data streaming to begin with. It introduces unneeded complexity in the early stages. I just don't try and run before you can walk. Like, if I would point this to anything, it'd be like, don't jump off a cliff and try and build the airplane while you're falling. Design data layer in mind that you will eventually require the real-time data streaming. Like I said, begins and ends with data. If you want to try and overhaul that at some point further down the road, it will be a pain in the ass. So at least if you leave the option open to real-time in the data layer, just not focusing on it, you can at least go back and revisit the problem. Try and avoid a hard dependency on specific inference engines as well. Easier said than done. You end up like anything in life. Hands up if you're a software engineer and you like abstracting multiple things. I certainly don't, but sometimes you get the business requirement to, and you end up having to waste a lot of time and effort for something that may or may not work in future. Try and avoid a dependency or hard dependency on infrastructure like a cloud provider. Hands up if you're currently having to consume multiple cloud providers because you can't get the resources from a single one. How much have you abstracted at Siggy? So just managed like EKS on Amazon, something like that. So things like that. So yeah, that's the same sort of path we took to being able to deploy into different backends, whether it's Stelia Cloud, whether it's AWS. If we can at least have a sort of deterministic managed Kubernetes target, we can then sort of support multiple backends from the products further up the stack. It's not great, but it's at least, it doesn't get me out of bed at 3 in the morning yet. I'm sure that will change. Design the API and optionally the AI as well, gateway, with a clean opinionated upfront specification. I say this with regards to software like API 6, where you have a AI gateway alongside the API gateway, and you can do model proxying and other things there. One of the things we tried out on a product level was being able to sort of proxy between different backends depending on availability, latency, or even cost. being able to, if you were consuming like real-time GCP and AWS, you'd be able to say GCP is currently cheaper for Llama 4 Scout, proxy to that. And while when you're consuming a case study of one user, it doesn't seem like a lot. When you're thinking about 10,000 users, the economics definitely stack up. Design the observability layer with large volumes of data in mind. This is again sort of obvious but not obvious. My ad tech background, we started off with real-time data in like the sort of 500,000 ballpark. And within a couple of years, we were taking in sort of 5 million events per second. That was an average day. Days like Black Friday, any sort of massive holiday, Amazon Prime Day, anything like this, we were spiking into double digits, millions per second. You would have infrastructure falling over. So designing that in mind is always, let's be honest, what I'm getting at is don't go building this around a single RabbitMQ instance that can only take 50,000 messages. Friends don't let friends use RabbitMQ. Design with governance in mind. Like you need to have a sort of product understanding of what you're building to begin with. Again, if I was targeting the ad tech space, I might not have went after thinking about showing bad adverts to children in mind in the early stages. I might, if I was only building a chatbot, everything just works until you end up getting lawsuits because your chatbot convinced someone to commit suicide or whatever. All sorts of lawsuits coming out these days with ChatGPT now being a therapist and a counselor and anything you ask it to do. Guardrails also important in that case. I would say most importantly as well, continuous learning is not a requirement for early stage, though definitely worth to keep in mind for the future. Have a strong of an understanding of the product as early on as possible, especially the overlap with the business use case. Ad tech, big one there. Continual ad generation, audience segmentation, multimodal ad matching, campaign summarization. Campaign summarization was a big one that we done.
Dave, we're running a bit over time.
Oh, this is my last slide. Model type, like I said, MOE works really well, but bursty workloads in ad tech, not really ideal because it only activates a subset of the model active, or subset of the models active per request. If I've got 10,000 requests coming in, those are all different shapes and sizes, but I've got a very static, like maybe 500s NVIDIA H200s or B200s that don't necessarily accommodate that burstiness at the moment. It might change in the future. Different experts can implicitly optimize for various things: dialogue, creative generation, reasoning, summarization. However, they also operate at operational complexities, like I said, routing complexity, memory pressure, GPU utilization, observability. Key takeaways: production inference products tailored to specific markets from a tech point of view is actually only like 20% on the model, and the rest of it is all around sort of data engineering, everything else. From the product perspective, it's probably sort of 1/3 each, I would say. And definitely having a good understanding of the use case. It helps if you've got a strong CTO or CPO, maybe doing the one job or can work together on that. The real challenge is understanding that the model is just one component, and the challenge begins bringing everything around that. Questions? Sorry for going a bit over time. Anyone? If not, I'm not difficult to find. I'll be over there.